Guys, have you ever dreamed of having your own personal financial coach? I'm sure that the answer is a big yes. But coaching is expensive, and you'd rather save this money for vacations, entertainment, or family. But guys, in the age of AI agents, you don't need to spend a cent because you can build your own AI financial coach. And in this video, I will show you how easy it is to do it.
Let's take a look at our application that uses AI agents to provide us with a financial coaching. So this is how our application looks like. I will put the link to the source code in the video description. So in our application, we can select the provider. As you see here, it can be Google, Anthropic, or so on. We can choose the model. So here I put Gemini models with the Google provider selection. But if you select Anthropic, for example, you will have other models like models from the Claude family. In this case, I'm gonna use Google model, the 3.1 Pro preview for all the agents. Of course, you need to provide the API key. Our application uses Google ADK, which stands for Agent Development Kit, which is very used in this kind of agent-based applications where we need to orchestrate different agents to have a final result. So in our application, we need to provide the agents with the monthly income. This is just an example to see how it works. Number of dependents, only one. We have two ways to insert our expenses. Either you upload a CSV file and you have the format precised here. You need to put the date of each transaction, the category, and the amount. So in my case, I've already prepared a test CSV file. It's just a toy example where I put some expenses just to show you how our financial coach works. So based on my CSV file, this is the total of the expenses. In total, we have 26 transactions. And the dates range from the 1st of January to the 31st of January, so it's only for 1 month. Here, guys, it's the aggregation of all the amounts which are part of the same category. So here we have category of entertainment, so this is the sum or the total of all transactions which are part of the category entertainment, and here we have the total of the transactions. So this is based on our CSV file, a sample of the transactions. So in their original format, we have the date, we have the category, and have amount. And these ones, this is just a part of our CSV file. But after aggregating all the transactions, we find all of them here with all the expenses part of the same category summed up together. Also, we can provide debt information if existing. So in this case, I've put two debt information. The first one is related to a credit card with $5,000 on it. The interest rate is 19% and the minimum needed payment is equals to $50. And there is another debt, which is university loan with $15,000 on it, 5% of interest. So this is to be noticed, guys, like the interest is not the same because later on one of our agents will consider this. It will start with the debt with the higher interest, and we have our minimum payment. Once we insert all this information, we click on Analyze Finances. After that, we will have our agents working on all this data. So in total, now once our agents finish their analysis, they provide us with insights on our expenses and their recommendations. But before going into details of the agent's insights and recommendations, let's check out what do we have as agents before. So here what we have, actually we have 3 agents in total. The first one is the budget analysis agent, which analyze spending patterns based on the data that we uploaded. It identifies areas for cost reduction and provides actionable recommendations. We have another one which provides the savings strategy, including a personal saving plans. It calculates the emergency fund and it suggests automation techniques. And we have a final one which takes into consideration the debts that we insert in the beginning and develops payoffs strategies, compares some repayment methods, and provides actionable debt reduction tips. Now, if we check out our agent's outputs, so here we have our first agent, which is the budget analysis. Here we have our pie chart where we have different expenses by categorization. Like here, the most expenses are related to housing, we have food, savings, and so on. And these are the percentage calculated by the agent based on the data that we uploaded in the application. So here, guys, it's to be mentioned that sometimes the model doesn't generate the good numbers here. There are some models which do better calculations than others, which is very normal. Like not all models perform the same, but this is part of the state of the models till this time. This is why one of the recommendations, guys, is not to give everything to be done by the agent, but you can provide the agent with some functions that can be seen as tools that the agent can use so that we can reduce the risk of errors made by these agents. Now let's go to this section where we have our income compared to our expenses. So here we have, by comparing the income and expenses, we have a surplus of 1,385. And here we have some spending recommendations. Here our agent is recommending us to implement a meal planning and bulk grocery shopping. It says that 675 for a two-person household is slightly above average, because here I've put that we have one dependent, so it's calculating for two persons, and based on the average that the model knows, it's slightly higher than the average, and this results in a 125 of saving. The next recommendation is to redirect a portion of 500 monthly savings toward the 19% interest credit card debt. So here the model is targeting the debt with the higher interest, and by calculating this interest reduction based on the 500 payment, we will have a potential monthly savings of 79. And the last recommendation is to reduce expenses related to personal expenses and entertainment. It says that 325 is high, and by reducing it to a 250 limit, it permits us to save around $75. So it's to be mentioned, guys, that with using another model, you might have different results. Sometimes numbers don't match, like you have some calculations that are not necessarily accurate related to our expenses or the suggestion of the model, but this is part of it. So that's why maybe doing these calculations in separate functions, and the model will use these calculations. Also, sometimes it makes some formatting errors, like here's formatting errors, but it's part of it, guys. Like this is what we have with these models nowadays, but this can be improved as well. This is just a first version of agents used for this purpose, but they can be improved. You can add functions as I mentioned. You can add some examples in the prompts that we will see later, where we give more specific examples that the model can follow and so on. So this is a very good starting point, but there are improvements that we can add to this version. If we go to the next agent, which is the savings strategy agent. So here the agent is talking about emergency fund, which is in average around 20K. It's supposed that we have 500 already in this emergency fund, but also it's recommending some savings in the strategy, like saving $100 per month to build the starter emergency fund, so which gonna be injected here, and the remaining amount will go to the high interest credit card debt. Here it's suggesting $400 per month to pay the high interest credit card debt. And here, if you notice, guys, the previous agent suggested to save 500 monthly if we go back to the previous agent, but this agent is talking about putting the whole 500 monthly savings toward this high interest debt. So these agents actually communicate between each other, because the second agent reads information provided by the first agent. So it saw that the first agent gave $500 saving as a recommendation, but this one, it refined that recommendation by splitting it into $400 for that high interest debt, and the remaining 100 gonna be used for the emergency fund. We have another $50 per month that the agent suggests to be dedicated for unexpected expenses related to the dependent. And at the end, as it's part of this agent definition, it provides automation techniques like the paycheck split and the automated debt payments. For the first one, it suggests that a direct deposit is automatically sent by the employer, and the second automatic payment will be scheduled by ourselves. And here, guys, see again the amounts. Like here we have $400, here we have $150. So if we try to understand why it's putting these amounts, because actually here we have the 400 that it's suggested to be put to pay the high interest credit card debt, and we have the remaining $100 for the emergency fund, and we have the $50 for the unexpected expenses here. So this is just to understand, but again, sometimes we don't have necessarily the good numbers. If we go to our last debt reduction, so the agent already summed up all debts that we have. So as a reminder, we had the $5,000 related to the credit card and the $15,000 related to the university loan. So it summed them up. We have 20K. Here we have some plots to represent these debts. And here we have the debt payoff plans. As you see here, guys, we have the avalanche method and the snowball method. They are actually very known techniques to pay debts. But here, if you notice, like we have exactly the same results for both techniques. So this is part of the things to be improved as well. But let's take a look at one of them. So here the model is supposing that this amount has already been paid. It's doing calculation for a 40 payments plan. So for the first recommendation, we have the same that we had in the previous agent, which is to redirect 400 of the 500 monthly saving to pay directly the credit card. It increases the debt payment to 550. This is maybe the summation of these 400 and the 150 that we are paying monthly for the university loan and the credit card. 100 plus 50, so it makes it 150 plus the 400, it makes it 550. The second suggestion is to consider a 0% introductory credit card if possible, so it makes us save the interest. This could save you over 500 in interest, but it's actually not 500 because the interest is not calculated like that. So this is another example of the agent's mistake, and I'm doing it on purpose to present this so that you will be aware of the kind of mistakes that can be made when we give the freedom to these agents to work with numbers. And here, if we take a look at the last recommendation, is to reallocate budget savings. And now if we take a look at the last recommendation, it's to apply to the 200 plus in potential savings identified by the budget analysis. And here it's precising, it's talking about the grocery and entertainment reductions. So if we go back to our budget analysis agent, it's talking about the 200 plus related to grocery. So we have here 125 and entertainment. So it's $201 and apply these savings to further accelerate debt payoffs. So you see here, guys, the agent knows what the other agent said, because what we will see here in the code, these agents communicate between each other and they actually share the information that they have after their operations. If we take a look at the code to parse quickly how we define these agents. So our agents are defined here in the finance advisor system. If we take a look at these agents, so they are here. We have the budget analysis agent, we have the savings strategy agent, and the debt reduction agent. And here we have the coordinator agent, which actually, as its name indicates, coordinates these agents. And this coordinator agent is putting these agents in sequence. So each agent gives its results to the following agent. And this is what we see here, our three agents, which work in sequence. And these agents behind the scenes, they share what we call a state. In this state, it's actually a dictionary where each agent writes in this dictionary in a separate key the output of the output or the outputs, if we have many, of its operations, so that the following agent will have the needed context. If we check our first agent, so we need to, it has a name. The model is the one that we choose in the application. Here we have a short description where we say that this agent analyzes financial data to categorize spending patterns and so on. So this is part of the way we define these agents. And in the instruction part, we give the model the instructions that we needed to follow. So here we give it what we call the role. You are a budget analysis agent specialized in reviewing financial transactions. We tell them that we have a critical instruction. It's related to the format. Sometimes we need a certain format and we want it to be respected, but there are other techniques, guys, where we force the format in a different way by using objects instead of leaving the model deciding or following these instructions. And here we give the model its tasks. So we tell it to analyze income, categorize spending, and so on for all the other tasks. We tell the model what to consider in its analysis. Here, guys, look here. We say for spending categories, include all expenses from the user's data, ensure percentage adds up to 100. So at the end, you always have 100. But again, based on the calculations, sometimes there are mistakes, but at least we mentioned that we want to end up with 100 at the end. But the intermediate percentage need to be verified. We provide some recommendations, like provide at least 3 to 5 specific actionable recommendations, explain the reasoning behind, consider quality of life, long-term financial health, and so on. And here we have a response schema example where we give examples to the model. Now at the end, here we precise the output schema and the output key. So for the output key, it's actually the key that I talked about that will be added in the state where the next agent will go to read the information provided by this agent. So the agent will put its output in this key that will be read by the following agent. This is for the output key. Also, this is the schema or the object that I talked about that we provide to the agent to avoid any anomalies in the agent output. So here it's what we call pedantic object. If we check this out, so here, see guys, what we want to have: total expenses, monthly income, and recommendations at the end. If we go and check our pedantic object here, we see that we have total expenses, monthly income, and recommendations, and this is a better way to control better the format of the model. And as you see here, we have many pedantic objects because we are using them in the different agents outputs. So this is for the first agents. For the next ones, we are doing it the same. I'm not going into details in how we define these agents, but I will provide the code so you can check it out later on. But it's the same way we define this agent as well. We give it a name, we give it a description, the instruction that we want it to follow. We tell the agent to read information from the budget analysis. This is the key. Here we have the state, and this is the key of the state. So this is the output of the previous agent, and we ask it to consider this information. So here we are giving the example of what we could have in numbers, but the schema is already verified thanks to the pedantic object that we provide here. And again, for this agent, we ask it to put the resulting output in the savings strategy key. And the last agent actually follows exactly the same rules: name, description, instructions. It reads from the other keys, and so on. This is actually for this part. I just wanted to show you how we define these agents. But if you need any other detail related to the code, don't hesitate to ask me in the video comments. This is it, guys, for today. I hope you like the application. This is again just a good start for these kind of applications, but there are many improvements to be done to have far better results and to have more consistent results as well. Thank you guys for watching. I hope you like the video. Don't hesitate to ask me questions in the comment if you have any, and see you next time.